Good afternoon, everybody. Welcome to DOM-based Angular Sandbox escapes. In this talk, I will demonstrate various sandbox escapes in different versions of Angular in a DOM-based context. And there'll be a live demo as well, so if you want to join, you can actually hack with me and try and break the sandbox. So if you want to open your laptops ready and open Chrome, then we can do that together, if you want to. So a little bit about me. I'm a researcher at Portswigger. I consider Portswigger the best web security company to work for right now. I really enjoy working there. I love every presentation, I always say this, but I love hacking JavaScript and browsers. I recently tweeted this. This uses the from function of the array constructor. The from function takes an array-like object in the first argument and converts it to an array, and then the second argument calls the function on every element of the array. So this results in alert 1. You can follow me on Twitter. I tweet about this sort of stuff. And what generally happens, I find this stuff and it leads to more interesting research. And then I do blog posts and talks about that. So the Angular Sandbox is a lot like an aging Mike Tyson. He's tough. He can take the punches. But luckily for us, he's not fighting anymore. Angular shipped on versions 1.0 without a sandbox. So from 1.0 to 1.15, there was no sandbox at all. But what happens in Angular is that expressions are scoped to an object that the developer creates. So when you call alert 1, for example, what you're actually doing is calling alert 1 on the scope object that the developer has assigned. And because the alert 1 function doesn't exist on that scope object, then the alert function won't be called. Mario discovered that you can get around this restriction and he could execute arbitrary code using expressions. And he did that using the constructor function. So here, constructor refers to the scope object constructor. And the scope object constructor is the object constructor. And the constructor of the object constructor is the function constructor. And the function constructor allows you to generate code and execute arbitrary code. So this will generate a function. You can then call that function, and then that will execute alert 1. Angular introduced a basic sandbox in 1.2.0. So they had an ensure safe member name function. And that function checked JavaScript properties for the word constructor. And it would throw an exception and prevent access to that. It also checked if there was an underscore at the start or at the end of the property name and threw an exception. So this is a very basic sandbox. Jan Horn found the first sandbox escape for version 1.2.0. So here, this is going to be complicated. I'll try to explain it as best as I can. He creates a new string with constructor in. He then creates an object literal. Then he uses the string that he's already created, which is, it's very hard to see from me there. So he uses a string there. And then he uses the sub function. So the sub function is an ancient JavaScript string method. And what that does is basically creates a sub tag. And it's been around in JavaScript for years. But the reason he uses that is simply as a shortcut in Angular to get a function. Once he's got a function, he can then use call. So a single function call to the call method will call the current function of the object, of the current function. So here, sub.call would call the sub function. But by using call.call, he gets the generic function method. And the generic function call method allows you to choose the function that you want to call. So here he uses his object literal, which is defined in B. He then uses square brackets and then with the string constructor in to get the object constructor. Once he's got the object constructor, he can then call getOnPropertyDescriptor. And what getOnPropertyDescriptor does is it returns a descriptor which is like an object literal, and it defines what that object property can do. So it will say if it's configurable, if it's enumerable, if it has getters, if it has setters, and finally if it's its value. So he calls getOnProperty descriptor with the first argument as the object that he wants to change, to get the descriptor of, sorry. So here he passes the object literal again with the constructor property. He uses getPrototypeOf, which gets the prototype of the object that you specify, and he passes the sub function shortcut again as a means to get a function. So that gets the function prototype as the first argument to the getOnProperty descriptor. And when the next argument in the getOnProperty descriptor function is the string constructor, so he passes that as the second argument. So this gets the property descriptor for the object literal, for the function prototype and the string constructor. So then value has a reference to the function constructor, because the descriptor, as I said, returns an object literal and has various properties, and the value has the value of that object property. So a value will actually be the function constructor. Then the generic call method accepts another argument. So this is the second argument of the generic call method. Here. So that argument assigns the object that you want the function to execute with. But for the function constructor, this is not important. It executes on the window. So he provides 0 as a minimal value for that. So it's not important. Then he passes the string alert1, which will call the function constructor, generate alert1, and then bypass the sandbox. Phew. Angular improved the sandbox quite a bit. They created an ensure safe member name. Well, they improved the ensure safe member name function. So this time they were checking for these properties directly. So if there was a define getter, define setter, lookup getter, lookup setter, or the proto property, and it would throw an exception. And they also added a new function called ensure safe object. So this is quite a cool function. It first checks to see if the object is truthy or not. So this will rule out null and undefined, for example, because you can't get a property on a null or an undefined object. And they check the constructor property. So this is a really cool check, because the constructor property of the function constructor is always itself. So this detects the function constructor. So this is a really cool check that works cross-domain. And they would throw an exception if you've got access to the function constructor, because as we've seen with Mario's exploit, you can execute arbitrary code. Then they have a similar check for the window object. So they use the window property and compare it to see if it matches itself, and this will detect the window, and this also works cross-domain. So it's a really cool check. They also check for a DOM node. So if this condition is true, then it will be detected as a DOM node. So that could be a document, it could be document.body, or an image object, whatever. Just a DOM node, and it will throw an exception. Now finally, they check the object to see if it matches the object constructor. So they do this because the constructor of the object constructor is in fact the function constructor. So they compare it directly with the object constructor in order to detect it, because this was the only way they could come up with doing that. Then we had a bit of a sandbox party. Me, Jan, Matthias, Gabor and Ian all broke the sandbox. And I did a blog post about my particular sandbox escape. So notice this is in the reflected context. It's not a DOM-based vector. But what my sandbox escape boiled down to was I modified the string prototype. And I changed the char@, function of every string object in JavaScript. And what the char@, function normally does is return a single character. But what I did was overwrote the string prototype method char@, so every string method now had this poison function. And what happens is, instead of it returning a single character, so normally when you call char@, you can pass like a number and it will return the character at that position. But what actually happens is the string returns all of its value and the joining character of whatever you specified. And the reason I did this is because in Angular, when it parses identifiers, it checks the result of this function and compares another character to see if it's less than the result of this function. But it will always be the case for a single character. So you can imagine they have some code like checking to see if A is less than this. And it'll always be the case because it's a longer character, a longer string. And so once we've done that, then we can call the eval function. And the reason we need to call the eval function is because we've broke the parser. So now we need to get it to execute again so that we can bypass the sandbox. So the $eval function is like an eval function in JavaScript, only it works in Angular. So then Angular now thinks that that string is an identifier, so we can execute arbitrary code and bypass the sandbox. Angular decided to leave the party, take the toys home, and remove the sandbox in version 1.6. You can boo if you like. That spoilt my fun. Is the fun over though? What about another context? What about a DOM-based context? After my talk in London about JSON hijacking, Lewis mentioned to me that Angular executes expressions in an order by filter, which I found really fascinating. He did a blog post about it, which you can find there with some code samples. But basically what it boils down to is a developer might introduce something into the scope that takes data from the location.hash. And once they've got that data in an ng repeat expression or whatever you call it, they will then, so you loop through the friends array. So friends is an array of objects. And the pipe operator, normally in JavaScript, is a bitwise OR operation. But in Angular, the pipe operator is a filter operation. So what you're saying is you take the friends array with an array of friends and objects, pass it to the order by filter. The colon signifies the argument that you want to pass to the order by filter. So here the order by is past the location.hash. So you use it for sorting data. So you could sort by telephone number, by name, etc. So it's a convenient way of sorting data. And what I found was that Angular was executing code here, but the previous sandbox escapes didn't work. And interestingly, the curlies that are normally required in Angular expressions are not required here. The most likely target for this would be in a DOM-based context using location.hash, because it provides a convenient way for the developer to change the state of the application without refreshing the page. So from 1.0.1 to 1.2.23, existing sandbox escapes work. But anything greater than 1.2.23, they don't work. So guess what? We need new sandbox escapes. So the first question I ask myself in this context is, what properties are available to me? So in this sandboxed environment, why are these previous publicly known sandbox escape not working in this context? So what properties were available to me? So in sandbox code, I extracted all the Angular source, got all the keywords out of the Angular source and JavaScript keywords, and then I went through every property and modified the string prototype and then prefixed it with an X and passed it property that I wanted to inspect and assigned it with the property that I wanted to inspect. So this is a way of getting data out of the sandbox environment into the normal JavaScript environment. So outside of sandbox code, I could then loop through this data and gather the information. So this would explain what functions are available. Is eval available, for example? I also created some helper methods. So here we have a keys function that returns the property names of an object. Then we have a log function that logs the object to the console. But what happened was the helper functions didn't work. So keys didn't work, logs didn't work, $eval didn't work, and watches didn't work. And the reason for this is interesting. So you might have remembered the array of objects on the left-hand side that was being passed to the order by filter. And what happens is the sandbox code is executed in the scope of the element of the array. So you're no longer in the developer's scope object. You're in the element of the array. So if you wanted these helper methods to work, for example, then you'd simply modify the array element and they would work. But this would explain why eval wasn't working. So I started hunting for bugs. So the first interesting thing that I found was array.toString can be called, I could call array.toString as a getter. And it calls the join function, which you'd probably expect, but it's pretty cool. So here we modify the function prototype, add a new getter. So define getter defines a getter on that object. X is the property that I want to add the getter on, and the function I want to call is array.toString. And I define a join function on that object, and the join function is called when the getter is accessed. This is pretty cool because it also works on window. So because window is an object, you can do toString equals array.toString. So in JavaScript, normally you're working on the window, so this is really window.toString. And then I add another property of join and then assign it to the alert function. And then when toString is called on window, the function will be executed. I couldn't find a way of passing arguments, but if you could, then you could bypass the sandbox. So to find my first sandbox escape, I looked at version 1.3.0. And in that big long list of property names that I fuzzed, I found that the function constructor was being called by the join method, as I showed you just before. But what was really interesting was I could get a reference to the object constructor using this technique. So here, you might notice that I'm using an array in an object accessor. So normally in JavaScript, you can have square brackets around an object property to enable you to pass characters that normally won't be allowed. It will also accept an expression. But here I pass an array. And what JavaScript does is it converts that into a string, and then that's fine for an object property. But the ensure-safe member name function is checking for proto. But I pass an array. And the ensure-safe member name function uses triple equals. So it's comparing for the string, and it's also comparing for the type. So because I pass an array, it is an array, so it's not a string, even though the string, when it gets converted, is proto. So this bypasses the ensure-safe member name function. So once I've got that, I can get the onProperty descriptor function, and then I can store a reference to it. Then we can use the getOnProperty descriptor with the function prototype. So I call getOnProperty descriptor. I use the sub function shortcut again to get the function prototype. So getOnProperty descriptor takes the first argument, the object, the second argument, the property. So I pass the function prototype and pass the string constructor. And this will get me a descriptor for the function constructor, which is really useful. So I store that in Y to use later. So Y will store the object descriptor for the function constructor. So now we need define property. And we need define property so that we can overwrite the constructor property. So I store a reference to define property using the same technique with the array. And then now we can use define property to overwrite the constructor property on every function. So here I call define property. So D contains a reference to the define property function. That function accepts 3 arguments. The first argument is the object. So I pass the sub function and get the function prototype again. Then the constructor is the property that I want to change. And the descriptor is just an object literal. And I want to change this property to false. But why do I want to do that? Well, if you look at the ensure-safe object function, it has a truthy check, and it's checking the constructor to equal itself. So I'm changing that value to false, so this will skip that check, and that exception will not be thrown. And now I can reuse the descriptor, and value contains a reference to the function constructor. So here we have the y property that I mentioned before. This is the descriptor. The value property refers to the function constructor. And if you call the function constructor with the string that you want to call, it will generate a new function, and then we can call that, and that will bypass the sandbox. So this is pretty cool. I go through all that trouble to avoid the word constructor. So the value property gets the function constructor without mentioning constructor, because now constructor is false. So that's why I go through all that trouble. So now this sandbox escape works on 1.2.24 to 1.2.26 and versions 1.3.0 to 1.3.1. That was cool, but I wanted more. I wanted to own more versions of the Angular sandbox in this context. So I thought, why don't we attack the rewriter? And the rewriter simply rewrites your JavaScript as valid JavaScript, but in a sandbox environment, so that you can't execute arbitrary code. But what I noticed was invalid JavaScript syntax was being rewritten as valid JavaScript syntax. So here we have some curlies. Now normally in JavaScript, if you begin a statement with curlies, it's a block statement. But your DevTools console lies to you. It gets converted into an object. And Angular also does the same and converts this into an object. So this is really an object literal. And then I use dot for the property. But instead of providing a valid dot, I use a semicolon. And guess what the rewriter does? The rewriter converts it into valid JavaScript. And you can see you can see the semicolon in pink there. That's been injected in the rewritten code as a valid JavaScript property. So Angular thinks that the semicolon is a JavaScript property. This is cool. So what if we use quotes? So we're using invalid JavaScript syntax, using a double quote as a property. What will Angular do? So I injected my curlies again with a double quote and got a Alexa error. Unterminated quote at columns 3 to 5. But what's interesting is that this is Alexa error. It's not saying syntax error as you would probably expect. So all we need to do is balance the quotes. And may I present to you the smallest possible Angular sandbox escape for version 1.2.27. And I challenge you to find a smaller one. So here we create an object literal, use dot, use a double quote, use a comma operator, call alert1, continue with another comma operator and then a double quote. And then Angular rewrites this code like so. So it breaks out of the double quote in the hasOwn property call. It calls alert1 and then continues the string. And you can see the rewritten code has our alert1 twice in the rewritten code. But it didn't work on the 1.3 branch. And I wondered why. So I looked at the rewritten code in the 1.3 branch. And I noticed the first alert was injected correctly. But notice the second alert is actually producing invalid JavaScript syntax. And if it's invalid syntax, there's no way Chrome is going to execute that. So our sandbox escape would fail on that branch. So what we need to do is break out of the parentheses and comment out that invalid syntax, and then we've got a sandbox escape for that version. So I modified the vector slightly to work on the entire 1.3 branch. So this works on all the versions of the 1.3 branch. So we have an object literal, we use dot, double quote, break out the parenthesis, execute alert1, and use a single line comment. So normally in a classic XSS vector, the double quote isn't required at the end of the comment because it doesn't matter because of the single line comment. But in Angular, we use that double quote to keep the Alexa happy so that it'll still work. And if you look at the rewritten code, you'll see the alert1 is called. Then I use a single line comment, and luckily for us, Angular puts all the rewritten code on one line, so we can use a single line comment which comments out the invalid syntax and bypasses the sandbox. So I'd like to give you a demo now, and if you've got your laptop open, then you can play along with me. So if you want to visit portswigger-labs.net/demo. I'm going to use my VM. So here is the URL that you want to visit if you want to do it, and here's the vector. So if you open up DevTools, and then click the Sources tab. And then you want to open up the Cloudflare folder online, but on here it's just index files. And then you want to open up the angular.js file. Then if you hit Control F or Command F, whatever operating system you're on, and search for new space function. So this will tell you, this will take you to the point in the Angular source where they check to see if CSP is active or not. So they call the function constructor with a string argument to see if CSP is activated. So we're not interested in that one, we need the next one. So I'll click Search Next. And now we need to add a breakpoint at 11192. And then if you scroll across, our code is actually going to be stored in the code variable in this version of Angular. So now we've added the breakpoint, we need to inject our vector, which is here. So click on the end of the URL, inject a hash, open curly, close curly, dot, double quote, comma, alert, opening parenthesis, 1, close parenthesis, comma, double quote. And then now we need to hit return. So we've modified the hash, but we need to reload the page now so that the debugger kicks in and stops at that breakpoint. So hit reload, and then fingers crossed, pray to the demo gods, yes. So we've got that breakpoint. So if you scroll across, the code variable now contains a string that's got JavaScript in it. But what you might notice is it doesn't contain our vector that we've injected. And this is because Angular is sandboxing the code multiple times for every element of the array. And what we need to do is hit resume on the debugger 5 times in order to see our rewritten code. So hit resume 5 times. 1, 2, 3, 4, 5. And now if we scroll across to that variable, you can see our injected code appears in the rewritten output. So the next time I hit resume, we'll get a flurry of alerts. This is because it's been sandboxed multiple times. Cool, so if anybody tried it, I hope you had some success. So then I started hunting for more bugs. I started to look at the 1.4 branch. The 1.4 branch was more challenging. The object constructor is protected correctly now, so I couldn't use the array trick with the proto property to get a reference to the object constructor. Identifiers are checked correctly now, so I couldn't XSS the rewriter. So I thought maybe we could overwrite global variables. So as I said, Angular forces a scope into the scope object that the developer defines. So normally you can't overwrite global variables. But if we use an object literal and we use proto.proto, proto.proto is the window global scope polluter. And we assign that to an object literal. And we use proto. Now proto is an important part here. So we assign proto to null so that that object does not inherit from any other object. And we need this in order to keep the assignment to the global scope polluter so that it'll work basically. And then we have an X property that we assign to 1, 2, 3. And we've got a global variable on window without specifying window dot, which is pretty cool, and that works in the Angular sandbox. This works on older versions of it works on IE 11 and older versions of Safari. thing is, we're not really getting a global variable. We've got the effect of a global variable, but what we're actually doing is we're modifying the global scope polluter prototype so we can create new properties, but we can't overwrite existing ones. So I couldn't use this for the hack. You might remember the ensure safe object function that I showed you earlier. So in Angular, there's an ensure safe object function, and it checks to see if the object is truthy or not. So what I thought, well, what about if I provide an object that is false? So here, I modify the Boolean prototype and then assign that to the function constructor. So now we've got an object that is false, but allows us to execute arbitrary code. So I thought maybe we could use that to skip that security check. And it does work, but it will only work on the false object. Every other property will be checked, so it won't bypass the sandbox. Another thought I had was maybe overwrite the function prototype. So here I use the function constructor and modify its prototype and assign it to null. And what that does is removes the constructor property. It's now undefined. And because we've made that undefined, we need access to the function constructor in order to execute code. So here we can use the function constructor .prototype.constructor, and we can execute alert 1. But in Angular, there is no way to overwrite the function prototype, the function constructor. You can only modify every function. So once you've modified and assigned the proto property to null, then constructor is removed on every function so that you can't access that later. So the attack failed. But interestingly, another thing I found was in Firefox 51, you can get the caller using lookup getter. So if we have a function of x which calls y, then the y function has a lookup getter method. We call the lookup getter and get the caller getter. And then we can call the caller getter and provide y as the argument. And this will return the caller for that function. So this is quite a cool hack to get a caller without specifying caller. And it only works on Firefox. It doesn't work on any other browser. But we don't have any functions in Angular, so I couldn't use this technique. But you'll see this later. Lookup getter did prove very interesting. Another thought I had was maybe aliasing the function constructor. And this is quite a cool trick. So we use the sub function shortcut again. We modify the function prototype. We define a new getter, and the getter is x, and the function that we want to call is value of. Now what that does is returns the value of the object. So now the function constructor has a property of x that allows us to execute arbitrary code without specifying function.constructor. So you can see where I was going with this. You could also use the proto getter in this way. So normally in Angular, the proto getter requires an object, and you can provide that object using bind, for example. So this provides, using define getter, provides a way of doing that, providing the object to the function without specifying bind. So here we have an object literal. We use define getter. We define a new getter of x. We use lookup getter and get the proto getter. So when the getter is called, the proto getter is called, and that will return the proto of the current object. So it's just a cool way of providing an object that normally a function requires that object. But what I needed was, can anybody guess? Say what you see. Window leak. I needed a window leak. So I thought maybe I could use lookup getter in the scope of window. So this is really cool. So in Chrome, what happens is when you alias a function like this, so here I use L and I assign it to lookup getter. So normally lookup getter is a member function, so it requires an object. Using a reference to a function in this way converts it to a general function. And when it's a general function, it loses the reference to the object. And now we can execute that function in the scope of window. So Chrome is the only browser that does this. So I call lookup getter, ask for the document getter, I get the document getter, call the document getter, and that will return the document. Then default view returns the current window, so we've got our window leak, and then I can execute alert 1. Define setter also works in this way. So again, I use define setter this time. I call define setter, which works on window, so it adds a new setter on window of y and calls the function alert. So when you assign to y, then the alert function will be called, and Chrome will be using the window object. Well, would this work in Angular? No, it wouldn't. And the reason it wouldn't is because the scope object is being forced on the function call. And so what we need to do is find a way of forcing Angular to execute as a general function, not as a member function. So a member function is when you call it from an object. A general function is when you're just calling the function without an object. And what we need to do, we need to talk about direct and indirect calls, because we can use this technique to force Angular to executing as a general function, not as a member function. So direct calls execute in the global scope. So if we have a y property of global, so we assign it to global, and we have a function of x, and a locally scoped y variable, which is assigned to local, and when you call eval, this is a direct call to eval. A direct call means that the code is eval, is native code eval, and its identifier is also eval. If those two conditions are true, then that's a direct call. So what y is assigned is in the local scope. So when alert is called, y is in the local scope, and so you get that data. Indirect calls are anything that the eval identifier is not eval. So an indirect call is like this. So we have a parenthesis expression. We use 1, comma, eval. So the comma operator returns the rightmost expression, which is eval. So the parenthesis expression will have a reference to eval. But because the eval function doesn't have an identifier of eval, that's an indirect call. And an indirect call executes in the global scope. So when that alert function is called, y will be in the scope of window, so it will be global. So I needed an indirect call to fool Angular. Angular doesn't support the comma operator. So I had a look at perfectionkills.com. It's a really cool resource. You should check it out. And there's plenty of indirect call examples on there. So I've showed you the classic one. We first discovered this on Slackers. Slackers was like a security forum many years ago that everybody did research on. So for example here, the eval on the left is not important because the comma operator always returns the expression on the right. So it's just another example of the one above. Ternary operations also produce an indirect call. So here we have a parenthesis expression. 1 evaluates to true. It returns eval. The parenthesis expression returns eval. We can then call eval as in the global scope. And interestingly, an assignment also works as an indirect call too. So I attempted to break 1.4. So I created an object literal. I had a reference to the lookup getter function using the array trick. Then I have an assignment. So I have an assignment. So L equals L. So L is equal to itself. So that's an assignment. That's like an indirect call. So we'll be forcing Angular to execute as a general function, not as a member function. We call lookup getter. Chrome executes that in the window scope. We get the document getter. We call the document getter, and we've got the document. Done, right? That should work. Any observant among you might wonder at the ensure safe object function. If we recap on the ensure safe object function on this particular line, it detects a DOM element. So document will be detected as a DOM element, and an exception will be thrown and access will be prevented. I love Chrome 57. Chrome 57 was like a birthday present to a security researcher such as myself. Because before the 57 update, the only getters on Windows were Proto and Document. But after 57, there are a lot more. And I fuzzed the list to get and extracted all the getters on Windows. So already with my Sandbox escape, I could call history.back, for example, but that's a bit lame. I could also call local storage and get and set local storage, but again, that's still a bit lame. But what really stood out was the event object getter. Using the event object getter, I was able to break the Sandbox again. And here's a Sandbox escape for 1.4. So we create an object literal. We use the array trick on the object accessor to get the lookup getter function. We use our indirect like call, so L equals L, and then we call the event getter. We call the event getter, and then target contains a reference to the document object. Then default view contains a reference to window. Then we can assign to location and bypass the Sandbox. So interestingly, you might be wondering why target is not detected as a document and why default view is not detected as a window. And I think it's because after the function call, for performance reasons, Angular doesn't bother checking those properties, luckily for me. And if you replace the location assignment, for example, with an alert 1, that will be detected as the window. And so the exploit will fail. So this is why I use a location assignment. This vector works on 1.4.0 to 1.4.5. I was going to end my presentation there, but it kept bugging me. How can we make previous Sandbox escapes work? There's no eval, right? $eval doesn't work. How can I do it? We need to go deeper. We need order by within order by. So if we call order by within order by, we've got our eval. So Angular has filters which are called from expressions. So here, for example, the string on the left is converted to uppercase with the filter on the right. So it's not a bitwise OR operation, it's a filter operation. So order by is an eval and it's a filter. So we can call order by from within order by. And here's a Sandbox escape for 1.5. So we create an object literal. We use a Y property. So normally in Angular in this version, you're prevented from assigning to the string prototype because of my char-at attack. So here I have a reference to the string prototype to get round the check in Angular. And then once I can get access to the string prototype and assign it, I can overwrite the char-at function and call array join. And as we've seen, that breaks the identifier check. So then we have an array on the left. The array is not important. We just need the order by filter to be our eval, basically. So the array is passed to the order by filter. The colon signifies the argument. And the argument we provide is arbitrary code, so we can execute whatever code we like. And Angular will think this is an identifier, and the Sandbox will be bypassed. This works on versions 1.5.0 to 1.5.8. I also attempted to break the latest version of the Angular Sandbox, so version 1.5.11. So normally Angular prevents you, in this version of Angular, that trick that I've just showed you on the previous slide doesn't work now. It will prevent access to modifying the string prototype. But if you pass it in an array and use the pipe operator in Angular, the filter operation, and then that will get passed to the order by filter, then we can modify the string prototype. So because X doesn't exist, Angular quite helpfully creates an object, and then we add a Y property with 1, 2, 3. So this allows us to modify the string prototype with an undefined object. It's cool, but it's not really useful. And also, we can modify the replace function value of. So if you could modify the replace function, then you could bypass the 1.5.11 version. But here I change value of to 1, 2, 3. So I can only change properties 2 levels deep. I can't change just 1 level deep. But maybe you can. I couldn't bypass 1.5.11, but you can have a go, try and do it. But I couldn't leave it there either. I needed to break 1.5.11. And what happens in Angular if you have an on-click event? So in Angular, that's ng-click. Angular has a $event object that it assigns to the event object in the JavaScript function. And interestingly, in Chrome, this event object has a path property. That path property is an array. And in that array, you might notice at the last element, there's the window object. So if I pass the path array to the order by filter, the Sandbox code will be executed in the scope of the array element. So it will loop through every element of the array until it gets to the window. So here we have an ng-click. We pass the path property to the order by filter. The order by filter will execute the code in the scope of the array element, and eventually it'll get to window, and then we can call alert1 and bypass the sandbox. But this doesn't work on the CSP mode. And the reason it doesn't work on the CSP mode is because Angular doesn't execute the code with the function constructor. But you might remember the vector that I started off with in the earlier slides. And you can get around that and bypass CSP mode using the from function. So we pass the path property to the order by filter. We pass the path property to the order by filter and then use array.constructor to get the array constructor, call the from function with array1. That gets converted to an array even though it's already an array. And then alert will be called on every element of the array and then bypass the sandbox. And that works in CSP mode. Thanks. I'd like to thank Mario, Jan, Matthias, Gabor, Ian and Lewis. I'd also like to thank Portswigger for enabling me to do the research. So my question to you is, can you find an exploit for greater than 1.5.8 outside of CSP mode? Thanks. Any questions? No?
No questions? Have you done any research in Angular 2 Plus? Obviously, architecture has changed.
Sorry, can you repeat that?
Have you done any research in Angular 2 Plus?
No, they've no sandbox in Angular, so it wasn't much fun for me. Because, you can bypass CSP mode because there's no sandbox. But Angular changes how you use HTML, so yeah, it's not really interesting for me.
Thanks a lot, Gareth.
Thanks.